Been a while since I've done this. But I hope I didn't mess anything up. Okay. So I'm just gonna start a new animation here and then animate this puzzle. Maybe I could do another one too. I'm just gonna start with this one and try to animate it well. So I'll just call it a square puzzle. Probably as good a name as any, and then this should be saved in my storage. Like so. Okay, so I think that's working. Okay. I guess I can see how long I can go before something totally breaks with this. I think mostly I'll just position all of these things, and once they're positioned, all the animation should be pretty straightforward from there. Auto play and stuff. Okay, so I can do that much. That's good. I should edit this to start with orthographic scene. That should do the same thing, and now I'm just gonna fill up with a bunch of these squares. Don't need either of those right now. Maybe I'll progress it with clicks or something like that. Great. Now let me... I just call this S1 or something. I hope there's a square object for one thing. Sure isn't. Okay. Or at least not when imported by default. But in the geometry... Is it like OpenGL geometry? There's an OpenGL square. Yeah, I guess I just renamed circle already? Okay. I'll just rename that. I wonder if there's... What OpenGL things I want to rename here? Arc? A lot of these things aren't actually useful in OpenGL. Ellipse I should probably rename. Dashed line, probably won't need. Tangent line, I don't think I understand. Maybe arrow. Maybe polygon. Or triangle, possibly. Mostly I think I don't need to deal with that. And then I'll just recompile that. I haven't done this in a while. No such container, that makes sense. Let's try that. Great. And this should already be saved. I'm more cautious about how the saving mechanic works. Okay, well, it seems to be working. So I'll just reload this. Mm. I didn't break anything. It's always hard to tell with these small changes. Oh, this. Pretty sure this is a transient error. Okay. Great. As for these colors, I wish I had a color picker, honestly. Let me do this. I have a labeled square. No, it doesn't need to be like part of this. Labeled square like this, and I can just do like side length and number. Or side length and label. I'll just create a V group like this. I'll just add in a square. I guess I'd want to add the label into the square, right? That might actually be simpler. So you do something like this. Square.add label. And return the square. And then this way, S1 I can have, hopefully, just labeled square. And I'll say like 5, like Math Tech 5. Okay. I wish I could get these colors quite right. For now, maybe I should just try to position these correctly. Oh, and the side length. Yeah, perfect. Now that looks a little too big, so I'm gonna have to go ahead and scale this. I guess I could just put like a square. Not just for the square, like a scale factor. This in scale, and this will just be like 0.6 or something like that. I can scale that like so. It'll make this a little more manageable. No, it shouldn't be like this. I should do it with model matrices. Because I should do everything with model matrices. Wait, why didn't this crash? Oh, I guess it still had this variable from the last time the program ran. Interesting. Am I gonna have like squares? Make this a V group. Then I'll just add this one in. How do I do like squares? Squares.s5 equals labeled square of this. And not mess that up. And then squares that add that. Actually, I don't even have to do that much. It doesn't have to be squares.s5. This can just be s5. Add s5 like this. Self.add squares. Okay, so I think this is working properly. I will want the LaTeX to have a constant size. I don't think I want that to be scaled. So if I do like squares, that model equals scale. And then what I want to do is scale this. That scales the number 2. Can I do this without updating the number? I guess it's... No, I actually don't think I can. That's unfortunate. I have to do something like self.distance scale factor equals O.6. Now scale the model matrix by this of the entire group. And then all of these math tech things, I'll have to scale the opposite way. Which is a little unfortunate. That means this will be specific to this. Side length and a label. Then at this point it looks more like maybe I could just do it without the model matrix in the first place. I think for now I won't do that. Yeah, I'll see how that works out. So at the regular side length, I'll scale the entire thing by this, the distance scale factor. Since I think I want everything scaled by this, but this, the label, I have label dot model and scale it the opposite way. And this should be self. Five in math tech 5. Let's write that properly. Okay. So as for how to translate this, let me add in S6. Now to move this to the bottom of S5, it should be S6 dot model equals, I want like the translation of S5 dot model and then base it off of that. Maybe this can just be the origin though. So maybe we can just say translation, or like y equals 5/2. I did that in the wrong direction. But yeah, then this also has to be exactly 5. Okay, why would that happen? Why would these not be aligned? That seems really strange to me. The entire squares group is scaled, but that shouldn't affect that. Let me see. So that only changed the size, which is what I expect. Wait, I think this makes sense actually. This should be would it be 6? This is at the center. I essentially want to move the top edge of the 6 square to the bottom. To the bottom of the 5 square. So I have to take the difference? Hold on. If I just do a -6 here, that's too much. So it's 5.5, which is the average, is one way to think of it. I feel like I must be doing some bad math here. Without this translation, it's located here. I want to move it from here. It's 6/2, so it's 3 above the origin. And from the origin to where I want this to be is 5/2. So this translation is -5/2 minus 6/2. Okay. So that's what I have to do. Fair enough. I actually want these labels to be a little bit bigger, I think. I should deal with that later. Right now, I actually think I want the scale factor even smaller. Okay, then I'm gonna move the entire squares group. Now, do y equals 2 or something. Okay, I'm gonna add the 2. I should actually put some thought into this. How will I want to move this? This should be -5/2 minus 6/2. So this will move it to where the 6 is. Then I'm going to move it again. Minus 6 over 2. This moves to the edge. How can I organize this? So like this, then same thing here. Plus 6 over 2. Then minus, and this is going to be 6 over 2 plus 2 over 2. Great. So I guess this isn't to scale, but it makes sense that this isn't to scale. Because this 2 obviously isn't a third of this 6. No, that's fine. Aligning these on the right side, that might be a little annoying. Or will it actually? I guess that's the next step now. Yeah, since to put the 4, 3, and 1 here, I'd have to align, basically align those on the right side. Right now the right side isn't aligned. So what's the X translation that I need for the 5 is the first thing to ask. So I'll just put 0 for now. So you need the difference between 5 over 2 and 6 over 2, right? So it should just be 6 over 2 minus 5 over 2. Okay, that wasn't nearly as bad as I expected. And this is going to be 6 over 2 minus 2 over 2. Great. Then let me put -2 translation or so on this. Great. Okay, so now I need the 4, 3, and 1 squares. Should be pretty similar to this. Now, one thing, there should be a way. Well, maybe that wouldn't be that helpful. I was thinking there should be a way to just take the translation from another square, which there is. But there's a chance that wouldn't be that helpful anyway. So here I'm just going to take the translation from S5 in this case. And just copy it and then add to that. So I need to move it additionally 5 over 2 plus 4 over 2. Okay. And for its y displacement, that's going to have to be 5 over 2 minus 4 over 2. Nope. It needs a negative. Okay, good. And that's perfect. This is always copy paste the wrong way. Okay, let's do the 3. I guess there isn't much point in passing this number twice. Side length. Let me just make the label here. Label equals map type. String of side length. I think this won't change anything. The difference being that I can take out this label argument entirely. And it'll just be simpler. Great. Okay, so let me translate that. It's going to be plus 3/2 plus 4/2. It's going to be a minus 4/2 minus 3/2. Great. I'll position the 1 square. It's going to be pretty much the same thing. Plus 3/2 plus 1/2. And then minus 3/2 minus 1/2. Great. So the scale looks a little bit different from this. But that's okay. Then I have to put in these 2 lines to form the triangle. Okay. Okay, that shouldn't be too hard. Mostly just getting the center of this, then that offset, then the center of this and that offset. So for one of these squares, maybe I should have like a get corner or something. Yeah, it's kind of... I guess that doesn't make too much sense. It would be kind of useful, but I think it's more code than I actually even need. Squares dot add S5, S6. Squares dot model. Self add squares. Okay, so I'm pretty much done with the squares. Oh, the thing is, I also want to scale everything by the scale factor pretty much. So maybe I should have another V group. Really, I wish you could scale the scene itself by a scale factor. But I won't do that. I won't do that now. I'll just add in the triangle lines separately. Triangle line top or something? I'll just have a line. I'll just put this left and right. Now add that in. Great. I have to do put start and end on. And I think I actually will want something like lines. Not self.lines equals v group. I do self.lines.model. And this will be that self.distance, whatever, this. I can do self.lines.add that. Then I have to add self.lines. Okay, and this did scale it a bit, which is correct. I really want to move all the square setup code into its own function. That'll just make this a lot cleaner. So I just do like an add squares. Just self. That can actually return this V group of squares. Yeah, this could be get squares or something. Or it could just be like setup squares. I can just add it as well. I'll try get squares. I feel like that's a little cleaner. I can just put all of this here, return the squares. If I can type here. And here I'll do self.add, self.get squares. Great. I'm gonna do something similar with the lines. Def get lines, something like that. I'll just copy this for now. And return it. I can do self.add. Self.get lines. Perfect. Great. Although this does have the disadvantage, I don't have the variable names of the squares, which is actually kind of annoying. Darn. Yeah, I think that makes it, that's actually reason enough not to do it. So much for being ordered. Okay, now I should figure out how to get these endpoints. So S5 bottom right equals, I'll do origin for now. Here it'd be really useful to be able to get the translation of an object, which I might be able to do, possibly. This would be something from OpenGL mobject, if it exists at all. There's the world translation. But not just the local translation. I should probably just add that. World translation? Does this name even make sense? I think I took this inspiration from 3JS where they have a function called matrix world. I think that's fine. I'll just write one's called model translation. And do self.model matrix at this. And it does not like that very much. Oh, yeah, it's not a function. Model translation. Great, because I end up doing that quite a lot. Okay, and reload that. Oh, I just saw these squares have areas 1, 2, 3, 4, 5, and 6. Which doesn't change that much. I read side lengths, so that's why the scale is different here. And it doesn't change that much. But I will have to change these offsets. That's the most annoying part. Oh well. So I just have to do this square root instead. Okay. Since I don't want to change the label. Labeled square, this will take this will be area. And side length will be area, square rooted. Label will be area though. Okay. So now that scale factor can be larger now. Well, I guess now that I can see it, I'll leave it where it was. Then I'll work on fixing these offsets. Because basically all of these, I'll just have to do square roots like all over the place. Oh. Wait, what happened there? I think, I was trying to think of a shortcut to do this. Maybe it's better just do it like this. Okay. Okay, this isn't so bad. Great. That one and this one. Great. So now I probably don't want to translate this whole thing 2 and 2. Maybe I can just leave. What if I just don't do this? It does look sort of weird in the corner like that. I guess I could square root those two. And I'll do that. Now this, the scale factor, this can be a little larger. And maybe it can even be 1. Oh. Yeah, I think that's good. Move this up a little bit. A little bit more. And move it to the left some. Great. Okay, so pretty much back where I was on this. Although I think this is, oh. Because this isn't even using self.scale factor. This should be 1 over this. Even though that's still too small. Maybe that's fine, actually. Like, this window itself is kind of small. So I won't mess with that right now. Okay, I'm gonna mess with it. Only a little bit, though. Oh, 0.1, 0.2, 0.1. Okay. So now... Now... I get to place the endpoints of this line. So S5 bottom right, this is going to be S5 dot model translation. Plus right times that side length over 2, and then plus down times that side length over 2. So it's going to be right plus down times this divided by 2. And what did I do? None type and float? Oh, I must have written this function wrong. Like, didn't return. I actually did the same thing here. Okay. See what we got here. That's fine. Doesn't crash anymore. So now do S5 bottom right. And that didn't work. Why? If I just put S5 model translation here. What's going on? Okay, it says 5. Oh, I want the... I think I will want the world translation or whatever. Because S5 has a parent, squares, and squares is translated. Huh. And this isn't added to the same parent. It should be, though. Oh, yeah, this is kind of weird. It's not supposed to be added to the same parent, so I don't want the model translation, and I do think I want the world translation. Okay. Plus right plus down. Okay, and this right plus down would be a problem if there was other transformations on 5. How would I do that normally? If there were more transformations on 5, I'd want to take its world translation. Maybe I'd want to do it manually. I'd want to bring the origin, S5's origin, into world space. Now I'm thinking about how the math do this. The model matrix will bring from model space to world space. So I'd want to bring its origin into world space. And then I'd want to bring its bottom right corner into world space. And that's how I would do it. So this world translation is bringing its origin into world space. This is not bringing its bottom right corner into world space in general. But I guess it is in this case. So I guess the more correct way to do this I'd say like S5 world matrix equals S5 dot, I forgot the name of that thing. No. Hierarchical model matrix, which maybe I should just rename that. Then what I want to do is S5 bottom right will be this vector moved into world space. Moved from S5's model space into world space. So I already have the vector. Oh, this will be annoying though. Like np dot append, I think. I have this comma 1. And then I'll multiply that by the S5 world matrix. And then take the first 3 of that. Is it not append? Is it concatenate or something dumb like that? values. Okay, maybe it's concatenate. Or is it concat? Or is it append? No, I have no idea. To 1B array. Really, it just needs to be a function, like model to world or something like that. Like np.concatenate a b. Wait, what? Append creates a new array. And it's like this. Okay, so that's how I do that. And this definitely needs its own function. World translation, model translation. I need like def, like vector to world, vector to model to world. And this can take a vector. And then I'll do basically this computation. np.append that with a 1. Vector comma 1. Multiply that by the whatever. That autocomplete messed me up. Self.world. Self.hierarchical model matrix. Okay. That's gonna bring it to world space. Maybe I should be even cleaner with this. Okay. Homogeneous vector. It's basically this. Then, world homogeneous vector. Goes this at a homogeneous vector. Return. Okay, and this is making it non-homogeneous. Even this is like kind of long for some reason, but whatever. Okay, so now I can now I can do computations in model space and bring those to world space. Should be really helpful. Now S5 bottom right, this should just be S5 dot model to world of this. Okay. Great, that finally worked. No, I don't need this line anymore. So that's nice. Actually, this might be concise enough now that I can just do this. S5.model to world of that. Then I want S1. Model to world up plus left times its side length. Great. Nice. Okay, nice. Triangle line top, so that's done. Let me get the right. Okay. And here I'll have S2. And that's right plus down times this distance. Oh, and the other one's already the way I want it. Okay, cool. So why don't you just check if I scale this now? Oh man, that's a little off. Why would that be the case? If I'm doing model to world here. Oh, it must be because this itself is scaled. So only if I removed this would it then match that scale. I'm slowly moving this back to just 2, -2, 2. Whatever. Okay, just to be consistent, I'll here put self.lines.add this. The top and then the right. Great. Then I want to label that angle. I'm just gonna have to label a few angles. So I have code for labeling an angle already. I'll just label this like set of squares. set of lines. And then they add the angle. Okay, now the angle code I'm going to have to take from the law of cosines or something. I thought I had angle code. Oh, I just, wait, triangle with altitudes. There's the angle. Now what does this take? Previous point and next point. Okay, and then it just has itself. That's where it's where the center is. Oh, and it's a function too. Wait, what? Oh, it calls that function, so it's trying to be dynamic. I guess it is being dynamic. Then I guess I could just call this mouse move update. Within draw or something, probably. On mouse move, I do that. Okay, I don't know if it necessarily makes sense to call it mouse move update. X and Y. Okay, but it does this with a draw range. I feel like it should just be update. But I'll take this as a starting point. And I should try to put this in its own file. I won't try to do it right now though. For now, I'll just put that here. The question is, like, if I were to update this, how would I do it? I guess I would have to take another previous point and another next point. And that's what I would have to do. But for now, I don't want this to be a function. Maybe we'll offset equals 1.2. Label equals theta, that's fine. Oh, I don't actually want a label right now. Previous vector. And just as it calls the previous point. Oh, it normalizes it there. Self.add, self.label. I will need the update code I used. Because I have to convert those 2 points into a draw range for the angle. Yeah, so basically all of this stuff. X and Y. Wait, what do I do with X and Y? Is it even used? It just calls that function. Okay. Yeah, this is gonna need some probably heavy-ish refactoring. But I'll just paste this in like so, and try to just add in an angle, maybe it's the next point. Angle equals angle. I'll just put in right and then right plus up. Okay, so I think this is doing what I expect. I think. Oh yeah, because it's just the circle. So this does make sense that it doesn't appear here. It's automatically doing mouse move update, which I don't understand. Oh, that's called from scene. Interesting. I don't know how I feel about that now. Well, I guess it makes sense that it would automatically call mouse move update. Right now I'll just call this update or something. Or actually, current point, previous point. And where's next point? I'll just make it so that none of these are functions anymore. And maybe now this won't crash at least. Okay, I think that's doing what I expect now. So now it's like, how should this update? What is the compute pre-vector here? Pre-vector times the label offset? Oh, just to move the... Wait, what? Previous vector, that's a point. It's taking the unit vector. Oh, and then it's offsetting it by that much. Does this make sense? Yeah, I guess it does. It actually does. Okay. So instead I'll just call this update. And here I'll call self.update. Pre-point and next point. And that's what this should be taking. It shouldn't have to save these, really. Since they should be like variable. So here it shouldn't be self, here. I think that's it. So that's good. And maybe that's it, actually. There's an update function. Oh, you know it might be annoying. I think update gets automatically called by Manim. And that's kind of annoying. If I could have seen that pie. I actually don't see it here. Next for... wait. Update animations. There's animation.update. Oh yeah, mobject from object itself.mobjects, object.update. But this, I think this is only called in play or something. Compile animation data. Interact. Update to time. This is called from play. But I don't think this is called automatically anywhere. At least not in the WebGL logic. Unless I did do that. I think the WebGL logic just calls it calls draw and it calls this update animations. Yeah. And it isn't called here, luckily. This code is really complicated. In a bad way. But anyway. So this should be safe. So now all I should have to do is move it to the right place. So that's the angle. Let me say like angle location. That's s2 dot model to world. Right plus down times 2, square root of 2 over 2. So this angle, right and right plus up won't be correct. It won't be the correct place, but I'll do angle.model. Okay, so that moved the angle there. Now I need to get the two locations. So one is just going to be up. This won't be so bad. Here's the angle location. It's going to be angle breathe and angle next, basically. It's going to be S5 dot whatever. Model to world. Right plus down. Take this square root divided by 2. No, wait. I think that's right. I want S1. Model to world, right plus up, or left plus up. Times 1 times, I want the square root of that, divided by 2. Let me see if I can do angle breathe. Angle next. So close. Okay, so why didn't that work? Angle prev, angle next. It's like it wants to be measured in the positive direction. Could that be it? Let me see what happens if I do this. Actually, even that's wrong. So that's a problem. And also the location of the theta doesn't make sense. Okay, I gotta see, I have to see what points these are. D equals dot. Translation, should be able to put angle prev. Okay, so that's the right location. That's the right location. So it must be something with the angle logic. Angle next and angle prev. If it's measuring in the positive direction, which means I'd want this one to be the prev. I might as well do that just to simplify the logic. Put prev here. Okay, because I'm also not sure why that happens. Let me not do that with the model. Oh, then do prev and then next. Can't tell if it's starting to work or not. It wants the previous and then the next. And to translate this, I shouldn't have just overridden that. Should have been this. But still. Well, I guess that angle is computed based on a location. So, if the... Wait. I guess the origin is like there, and that's why it's sweeping out that angle? But I have to know the center. I have to know like the location of this when I do it. Which is annoying. So how should this really work? It should have a... It needs a previous, a center, and a next. That's what it needs. So I have a center, previous, and next. then in this angle, I want to do this. And now I want to do this computation. In pre-vector, I want this minus the center. Then I have to do that in update. It still doesn't totally make sense why the theta would be over here, though. Hopefully I can figure that out. Then it takes this cur point. I'll just pass in a center. And this will be center. Her point is not defined. Oh, I want to do her point equals center here. Okay, then the angle works, but the theta is insane. And label offset vector. The pre-vector is based on the current point. The next vector is based on the current point. Basically needs to be rotated and translated. And this is translated by the start angle. What is angle here? The angle between the next vector and the previous vector? This is a weird function. I guess I'm rotating it by that much. Wonder what happens if I just translate this. Then it's rotated. It's translated by the wrong thing too, though. Previous vector divided by previous vector norm. The previous vector is here. Self.label. Self.label, it's added to the current matrix. So I'm going to start. I'm just not going to mess with the label here at all. Why is this rotated? Oh, because the entire thing is rotated. So draw range equals 0. Adds this label. Now to update the label. Oh, this was working off the assumption that the angle, the slope of the previous vector is 0, which is no longer true. So how do I get that? Angle arc cosine next and previous. I assume the order here. I don't know if that matters or not. I don't know why this one's next and then prev, and this one's prev and then next. Oh, but it's a dot product, so this is a scalar. So I can do prev and next. So if I want the angle of a vector, like angle from horizontal, how do I do that? And the angle would the dot product A dot B is this thing. Cosine of the angle between them. Theta. I feel like this isn't nearly as hard as I'm making it. Couldn't I just use an arc tangent? If I have that vector already. If I have this vector already. And I want this. Just find this x, this y, and do arc tangent. And like this will be y, this will be x. So prev vector angle. Do arctan. I think you're supposed to use atan or something. There's all these small things. Arctan 2 is the 4-quadrant arctan. What's atan 2? Or did I make that up? I guess this can handle zeros? As if just typing that in would be helpful. It takes a single number. Atan 2 takes 2 arguments. Okay, I think I do on arctan 2. Yeah. And then I just want star prev vector. Just kidding, I want the opposite of that. This at 1, then at 0. So the y, then the x. And prev vector angle is that. I think I want angle minus equals that. So close. The angle's the angle between these two. So we call label rotation. And this will be free vector angle plus angle over 2. No. Oh, I have to update it here. Still. A label offset vector. I wonder what this is. Oh, this is an offset along the pre-vector. That's interesting. I think that's not what I want. Pre-vector from here, the next vector. I think I want to deal with this rotation first. And so that should just be the pre-vector angle. I think. Wait, so much of this makes very little sense to me. How much is this rotated by? Z rotation matrix start angle, which is the angle of the pre-vector. So it's starting out rotated by this much. So that means not doing any of this stuff. I'm just gonna undo that. Okay, so now it's right side up. That's a start. And then from there, I just want to translate it, I think. And then the question is how much to translate it by? Or what's the right vector? I want the vector pretty much reeve. The prev angle rotated by theta over 2? I guess this is why I translated it. Okay, let me try this. Translate it by the pre-vector. I like this. That's not even the right direction. Isn't the pre-vector pointing that way? Pre-point minus curve point. Now that is the label offset vector. How is that pointing in that direction? It doesn't make any sense. Center pre-point next point. Yeah, the center, the angle prev is this point. And the angle next is this point. This is gonna end up being some heavy debugging. It's multiplied by the label offset here, but that shouldn't change the direction. Let's see. Okay, so that is in fact to the right. That's good. If I leave this empty. Oh, it's due to that rotation. It would be due to that. If I rotate and then translate it. Okay, so I'm rotating it here. Then I'm translating it. This translation is rotated. So that's what's happening. So I do this. Now it's rotated. I guess I want to translate it first. Okay. So now it's being translated to here, then it's being rotated. Wait, what does the translation alone do? I have to go back and try to adapt what I did before. It's so close, I think. This label offset vector. No, this angle was just angle. So I'm going to do the first thing I did before and undo that rotation by angle. Okay. Okay. So now the coordinate system is aligned with the x and the y axis. It's just y axis up, x axis to the right. Then I'm going to translate this. Along the previous vector. So let's try that. I actually do the syntax right. Or label offset vector. So this indicates that after doing this, its coordinate space wasn't aligned with the x and y axes. It couldn't have been. Maybe this should just be right. And it should. Now it's aligned at this location. And then I'll have to rotate it again by angle over 2. If I add the multiplication. Oh, it's so close, but the theta is a little offset. It's slightly rotated. So I guess this should be minus angle over 2? No, that's the wrong direction. So this should be minus angle. This should be a positive angle over 2? So close. Minus angle over 2. Okay, now it's upside up. Self.label offset. So then this label offset vector should just be right times that label offset. It still looks like it isn't right side up all the way. You must be getting something ever so slightly wrong. I'm gonna go back to here. And when this is just minus angle, here it's right side up. I think, pretty sure. Like if I undo the translation, and yeah, it looks right side up. Come on. But since I know I'm gonna rotate it by angle over 2, I don't want it to be right side up. So why is this not minus angle over 2? That doesn't make sense to me. It's slightly wrong now. And then when I multiply that by angle over 2, positive angle over 2. Now I don't know if it's upside up or not. I think it's not, though. Yeah, that line should be straight across. gonna try starting this from scratch again. Let me just try positioning it first. And if I do that, I should be able to handle the rotation separately. So here, it's currently rotated by the previous angle, because the entire shape is rotated by that much. So if I rotate it, let's do a negative of, not angle, but start angle. That I think was actually the problem. Oh, if I add the multiplication. Now it's right side up. But I want an additional rotation by angle over 2. Positive direction, angle over 2. Great. You have to counteract that and go on minus angle over 2. Okay, I did it. The theta is right side up now. It's funny because I don't think I actually even need that theta. Because in this picture it isn't labeled. But that's fine. I'll just update this default to 1.3. I feel like this should actually be smaller. Maybe if this was 0.8. Yeah, 1.1. Great. So that solves the positioning. And this might as well. I should just paste this in. Okay. So as for the solving, these distances aren't right anymore since these are the areas rather than the side lengths. It won't make any difference though. I guess we can just start by putting in the proper lengths and go from there. I can take off these dots. Now, let me just go through this step by step. So the first thing is you get this side. And you get this side. That's immediate. And you get that side. Okay, so you get this side. Then in order to get this side, you get this and this. And you use that to get this with Pythagorean theorem. Now you know the 8 and the root 50 and the 7. And you can get theta pretty much immediately just using a sine. And from there, oh, then you know this angle, the large one. Then I use law of sines, I think. No, then I use law of cosines to get this side. I use law of sines to get this angle. Is there any simpler way to do that? Once I know the large angle and the two sides, I think that's really a pretty classic law of cosine situation. Side angle side. Do a squared plus b squared minus 2 ab cosine c. Make sure I got the law of sines right, or cosines right. Yeah, I need this. The only angle you need is the angle opposite c. So yeah, that's how I get this. And then I can use law of sines. So let me start by getting a distance indicator, which I think I can take from the law of sines code, or law of cosines code. How would I call that? Triangle with altitudes. Length indicator. It's fairly straightforward. Maybe I should copy this into, wait. Let's start and end on. How did I do rotations or whatever? I guess since since it's composed of lines, I just stretched. I just did transformations on the entire line. But it'd be nice if this object had its own put start and end on function. Left distance indicator. Oh, well. I can say length indicator equals this. Okay, so it's just like that. But without a put start and end on. Or maybe I can just use put start and end on. That actually would make a lot of sense. Since this is inheriting from line, I can just do... It should be like left length indicator. Put start and end on. And it'll be... Honestly, I need a name for the bottom right corner of the 5. I should just have a name for that. It's like S5 bottom right. To just put that, have a variable of that. Then S1 bottom left. Okay, so that does the same thing. Then I have the S2 bottom right. And S1 bottom left. Okay, so that's exactly the same. Angle location. Now I can simplify this. Actually, simplify all of these, I think. This S2 bottom right. Previous is S1 whatever. And then next is S5 bottom right. I actually wonder how this would look in one line. I really should add them keystrokes to this. Save me some time. Yeah, like a better split up. I'll add that angle. And put start and end on. This will be the S2 bottom right and the S5 bottom right. Now left length. Wait, how long was that error there? Okay, I guess it was fine. Plus left. And here also plus left. Left times less than that. It's like O dot 1. O dot 1. Times left, like so. It needs to be larger. Okay, and this is probably gonna have to have some color to it. Let's make that red or something. Oh, I can't pass the stroke color here. Guess I don't think that matters. I don't know, purple, sure. No, I'll go with blue. Yeah. Great. So I need this, and then I got to have that root 6 plus root 2. Yeah. So left length label. Square root 6. Hope that's how you do that, because I actually think it's not. Shouldn't this be like this? Interesting. So since I don't want it to warp it like that, how should I do this? Stroke color blue. Yeah, I guess I will have to call this indicator. I didn't want to, just because the word is kind of long to type. It's not a big deal. Okay, so then I'll have left blank here. Then I'll have the indicator. Actually do it this way. The indicator, then the label. And left blank dot add. Both of those. I'll do it that way. Although now this needs to be positioned. Yeah, that's not a big deal. And that is the wrong direction. Let me just do x equals negative 1.5 or so. And then y equals this. That took way too long to autoplay. That's more like it. And then I'll just color this blue. Yeah, just so it stands out, I guess. It could be a lighter blue, maybe. I shouldn't be trying to do anything with the colors right now. Okay, sure. Maybe I want it smaller. Let me scale it, then translate it. Oh, yeah. 0.9, can I get away with 0.8? I'll do 0.9. Okay, good. I like how that looks. So I'll have that. Then I'll need this distance and this, well, that's just 1. So this will be root 7, this will be root 1, and this will be the square root of those two. So that isn't so difficult. Then I'll want to get rid of that, of the 7 and the 1 indicators when I'm animating it. That's for the top distance. I have pretty similar things to this, actually. I wonder how... There's probably a way to make this a little faster. If I have like a function that takes a function that returns an indicator with a label. Yeah. So for example, solve on the start, the end, the label location. Should be the label offset. Probably just a label location. I guess if I didn't... Yeah, I'll just have the label location. Yeah, and that's all. And then the goal is that eventually I want this to be just self dot get labeled length of whatever. So this left length equals self dot labeled length. This will be the start. This will be the end. And that label location will be this, down times 2 plus left times 1.2. I'm going to replace this with just start. And this was just end. And I can just pass this in. Of the label here, and then its location. I guess I won't do the color there. That doesn't really make sense. All of these lefts that I don't want. I can just do this. The label is already handed to me. So I just want to do label dot model equals this translation times whatever it already was. And return this. Should be labeled length. Well, that's right, the name. Maybe group or something. Like labels not defined. One. Oh, it's just label here. Great. Oh, it worked. Interesting. Okay, let me not do the color here. It just looks kind of awkward. Oh, the translation here. This should be star of the location. Okay, now what did I do? Oh, I didn't do star. Two times down, 1.2 times left. I wonder why that offsetted it some. I guess it doesn't matter. That's kind of weird though. Label location. Why would this have no effect? Label.model. Okay, I think it's crashed or something. Yeah. Yeah, I think it ran out of memory or something. Okay. Okay, so this makes sense. Then I'm just gonna color out this entire thing. Like blue. So now that I've done all that work, hopefully it'll be easier to do this for the root 4 plus root 3. This will be S5 bottom right to S1 bottom left. I'll do this times down. 4 plus 3. And I'll leave that at the origin for now. Oh, it's 7 length. Oh, I need the bottom left. Oh, what was this just wrong? S1 bottom left is the top left. S1 bottom left doesn't have a name yet. But I will need that, so... Okay, so that's what it's supposed to be. Maybe this should... part of me thinks this should be offset from the center of the line. I think that would make more sense. I don't know, maybe this should be down or something. Yeah, maybe just slightly up. Okay. Okay, so... I think I do want this to be offset from the center. But... do I want to do that? I'm trying to think if I want to do it now. I think it should be fairly quick. This translation should be length indicator dot model translation. What's the name of that thing? Model translation. Length indicator. Great, now it's offset from the center. Well, it's not offset. But this one will just be like left, I think. Maybe. And this one will just be down. And then this can be label offset plus this. Yeah, okay. This gonna be like 1.1 times that. This gonna be 0.1 times that. Yeah. Okay, then if I also know that this one's length 1, Then I'll be able to get this Pythagorean theorem. And then I'll be able to get that angle. And so on. Okay. Alright, I'm going to take a break from this now. Right here. Made a fair amount of progress with 181 lines here. It is getting a lot faster to do this, so that's nice. I wish I had something to compare with, like how long this would take to do using a local version, but this feels fairly fast. Especially since sometimes I have to write new stuff as I go. Okay, but I'm going to cut this here.